So we created John and we say, what's the value of John? Now notice this guy here. John is this name, that's the global namespace name, right? The overarching namespace. It's not emptiness, it's called underscore underscore main underscore underscore. So under this global namespace dot employee, we have just created a new data type, and it's an object instance. That means it has meat. It's occupying memory. It has its own first name, last name, company title, which is different from other instances. It's an object, and it's occupying this particular memory space at some part of the chip that's labeled 0x00019536 and so on. Okay, so this is an object that will be different if we created a different William object. Okay, so then we print on and inspect what is the class name of John, or rather, what is the data type. Notice here that when we say type of John, it is not list, dictionary, set, none of those that we have recognized. It is a new user created class. So for now, I'm using the word class and user created data type interchangeably, because strictly speaking, class is a lot more, it's much more powerful, it's richer in support than just a passive static user created data type. But of course, class can always be used just for that, and we are using it just for that. And it's already very powerful, right? Because we have elevated ourselves from just list and dictionary and set and tuple to a lot more, infinite, many more data types that we care to create that make sense in our business applications. So what is the is John an employee? That means our company employee? And answer is true, because we ask using this particular function, is John an instance? That means, is it created out of the employee data type class? And answer is yes, because we did that, right? We did that. And of course, this will verify that it is actually an employee data type. What is John's title? So we say John dot company title. Not surprisingly, we created John by supplying title, right? So vice president, and assigning that title to the internal storage area of John, which is company title. So that part of the internal storage is called company title, and that's for John. And when we inspect it by saying John dot company title, the same value, vice president, is going to come back up, and there we go, right? So recently, John was promoted to senior vice president. So what should we do about it? We like to update John's title, only John's title, not William's title. So we can do a dot company, same thing. The same syntax for accessing, for reading the value, now is placed on the left-hand side of the equality assignment, and that makes it an assignment target. So we now assign this new value to update the title, not the first name, not the last name. So now what's John's title? John dot company title. That's fine. Let's just create, another person, another employee, Will, and his name is called Will Smith. Okay. And he is general manager. All right. Then we can do the same and print out. Okay. So we know all these about John. And notice that the memory address has been changed, because depending on your machine setup and your applications that are running, it's occupying memory space. And when we create John, it needs memory space. Either it's going to search for new unoccupied area and reserve that space, and that will be the space that happens to be John. What about William? Will. So we say, Will, where are you? It is, of course, of type employee, right? Not surprising, but at a different memory address, which has to be different, because Will is not John. So we ask, is Will John? Well, shouldn't have a question mark. No, obviously they are not, right? So is Will an instance of employee? Notice that the employee is not a string, but the direct data type. Okay. We are passing the direct data type object to the function is instance. Just be aware of that. We are not passing a string here. What did I do wrong? Oh, sorry, I spelled it correctly. Is instance of will employee? Of course, right? So Will is part of employee, John is part of employee, and of course you can have many, many more, right? Creation of employees. I hope now your imagination is running wild. Oh, that means I can have 100 variables, call them differently, and they're all part of the same company. They're all employee of this company, and they're all called differently, and they can interact with each other. And yes, it's that is the power of class and creating your own data structure. So now we can have we updated John's company title, all right, is senior VP, right? How about Will's company title? Well, they don't share the same memory. So it is still general manager. Doesn't mean when we change John's title, Will's title will be changed. It's different employee. Okay. Yeah. So let's let's see. Let's do a scan of John. So all these underscore, they're automatically the method functions that are added on by Python. All of them are having very intricate, sensitive roles within Python system itself. So the variable John interacts with the Python language and the system in very invisible and yet very well-defined ways that we don't try to meddle around with unless you know what you're doing. So all the underscore methods here, functions here, try not to touch them, try not to run them by yourself. There's usually no need to change them or call them explicitly. But when there are names like these, you have to start wondering, hey, they look familiar, right? Yes, because we defined them, right? So these, not methods, but rather variable names, they exist in the data type employee. Yeah? And of course, we can also create functions within and they become functions, just like system-defined functions. But that starts to get involved in the object-oriented programming idea of thinking about things, thinking about variables. And I would not want to go into that area for now, because right now we are trying to learn how in Python can we create our own user data structure. And we can. And the answer is to use the class operator to create our own structure, our own set of well-defined fields of data, each having different data types, possibly by using the init setup. So this is the one case that we know what to do, and we are therefore able to take control of that and rewrite that. Okay, by also inserting self as the starting variable. Now, again, also there is no restriction that we have to use string. We could also have a self.age, self.salary that can be stored with floating point data type. So that's perfectly fine. Okay, so that's just a bit of an introduction into structured data type by using Python's class keyword. The class keyword has got a lot more to offer, and we shouldn't wait. So we start doing this now. And once we are confident with just using class as a static data type descriptor constructor to create larger data structures and data types, our own way of describing data. Once we are comfortable with that, then getting into object-oriented programming will become a much easier step rather than to jump from a flat programming world to object-oriented programming methodologies. So right now, I think this is a good interim step to think of using class to create as a means of creating our own static data structures. Okay, that's all for data type that I want to get into as a beginner's class. And already I think that's a lot. So just leave you with some time to think about what to do next with reviewing the stuff and having more practice. I'll see you in the next set of videos. Bye.